So let's look at couple of questions. The first question is, what is the current through 10 kilo ohm resistance? That is the current through this resistance. The next question is, derive the current equation through 2 microfarad capacitance. That means the current equation through this capacitor. And the third question is, what is the current through collector? That is the value of IC. And what is the emitter to collector voltage? So in all the three questions, there is one element common, and that element is Thevenin's theorem. So today we will see how all these three questions can be solved using Thevenin's theorem, because that's the common concept across all these three questions. Let's go to the first question. So to solve the first problem, let's find out the Thevenin's voltage and the Thevenin's resistance at this point, because here our load is 10K. So what Thevenin's theorem tells? First we will find out the Thevenin's voltage, and to find the Thevenin's voltage, we are going to remove this target resistance. So our new circuit will look like so what is the voltage here? So V Thevenin is nothing but 11 by 2, that is 5.5 volt. So now let's also find out the Thevenin's resistance. So to find out Thevenin's resistance, the procedure is the voltage source should be replaced by ground, and from this point we are going to find out what is the effective resistance. So what is the effective resistance? 2K and 2K in parallel. So essentially effective resistance is 1K, and this is called R Thevenin. So the network can be redrawn as V Thevenin, that is 5.5 volt, R Thevenin, that is 1 kilo ohm, and our original 10 kilo. So now if we try to find out the current equation, it is pretty straightforward. So what will be the current? The current I will be 5.5 volt, that is V Thevenin by 10K plus 1K. So essentially 5.5 volt by 11K, which is 0.5 milliampere. So the steps are pretty simple. For this target resistance 10 kilo ohm, we are first going to remove it. Then the effective circuit will look like this, and then we are going to first find out the Thevenin's voltage. Then we are going to find out the Thevenin's resistance. For that, the voltage source should be replaced with ground. And once we find out both Thevenin's resistance and Thevenin's voltage, the circuit can be simplified as V Thevenin plus R Thevenin, and then the actual load, that is 10K. So let's look at the second problem. Similarly here, our target load is 2 microfarad. So we are going to remove the target load, and we are going to first find out the Thevenin's voltage. So our circuit will look like so what will be the voltage here? V Thevenin will be nothing but 2 volt multiplied by 5K by 5K plus 5K. So essentially 1 volt. So first we found out the Thevenin voltage, and now let's find out the Thevenin resistance. And for that, what is our rule? The voltage source will be replaced by ground. And from this point, we are going to find out the effective resistance. So essentially 5K and 5K in parallel. So the effective resistance is 2.5K. That is our R Thevenin. So the circuit can be redrawn as V Thevenin, which is 1 volt, R Thevenin, which is 2.5 kilo ohm, and then our load. Two microfarad. So now it's very straightforward. So if we have a voltage source V, a resistance R, and a capacitance C, we know the current equation is given by IT equal to V by R e to the power minus T by RC. And here our V equal to 1 volt, R equal to 2.5 kilo ohm, and C equal to 2 microfarad.